all the input parameters coming, this is an engine. The input parameters are coming from, give me one input parameter. Excuse me, the throttle position, the power, positive and negative, enter here. Other input parameter important for an engine. The fuel, pressure, a lot of parameters, no? Pressure, temperature, all of those parameters enter here. That's the input. And this is the output. To activate sensor, to activate, yeah? Tan, 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 tan. Input and out. And the rest are individual circuits. What circuit you think you have here integrated in this board? Give me an example of one circuit. The circuit for cranking. You remember the circuit that we did? Ignition switch, relay, and the relay solenoid, and the solenoid motor, and start the engine. You remember that? This is one circuit. Oh, nice. One circuit is one path here. Okay, nice. Give me other example of other circuit.
The kill switch.
Excuse me?
The kill switch.
The kill, to kill, is other circuit. Other circuit is the fuel for the injectors. To open the injectors, other circuit. Other circuit for
the preheat.
The preheat, the stop. Circuit, individual circuits. No? There are millions of circuits in an engine. All of those circuits are integrated here. But this is the final product. You remember that we start in the previous class, until this moment we create only one or two circuits. Only the cranking and the stop, and probably half of the fuel. You remember? Because we activate the fuel pump and the solenoid of the fuel injection pump. You remember that? We have basically 2.5 complete circuits to create the harness of a big engine. And we have the circuit for the gauge. You remember? The gauge for the oil pressure gauge, temperature gauge. We have like 5 circuits. Great. But how many circuits are in a typical computer for an engine? 200? Something like this. No, it's a lot of circuits, a lot of components. What is the procedure to create a final product like this? The final product is this. This is the computer of an engine, and those are the inputs, and those are the outputs. But here, if you remove that plastic, that foam, you have the board. And they have resin over there, and the board is covered, the circuit board. But the board have the resistor, the capacitor, the diodes, all of those elements, circuit by circuit. Each pin, one pin is the input and other pin is the output of one circuit. The second pin is other. For that reason, when you see the wiring diagram, you say, oh, I have a problem in the injector number 2. Okay, the input is, in this socket, is the pin 17. And the output for injector 2, according with the diagram, is the pin 12. I need verify when the engine is running with an alligator cable, in the pin 17. Here, I connect my voltmeter, ground, and here, and I check if I have 4.7 volts. Oh, 0. You understand? What happened with the circuit for the injector number 2 is open or is broken. And I need to replace the computer. Everybody follow me?
Can you take that apart to repair a broken connection, or do you have to replace that whole thing?
Normally, in marine application, you need to replace the computer.
Or automotive. Like if it's that exact, the ECU for the car.
If the circuit board is open, not covered with resin like this, you can fix it. Like this one.
So you can't take it apart if it's covered with resin?
Yeah, in some cases it's possible. I'm going to explain the procedure.
What happens is not all of them have an output, they only have one input. It's like one connection. How do you test it? Would it be the same thing?
No, always, when you remove that connector, you find the pins.
I know, but like, there's not always a second one of these. There's only one of these.
Oh, if you have only one of these, one row is input and the bottom one is output, or vice versa. Okay. It's integrated, both of them, in that socket.
Okay.
Yeah, but you always have inputs and outputs.
Right.
Always, always, always. Oh, I have 17 pins. That's it, Mr. Lopez. Okay, probably 6 are inputs, and the other 12 are outputs. No? No, guys? Okay? Papi, I need concentration because this topic is a lot of information, right? This is a circuit board. But let me explain the procedure. Let me explain the procedure to create a board. Okay, what is this?
Circuit board.
It's a board clean, only with the holes. No, and the holes, each hole is independent of the next one, completely isolated. No, the holes are separated.
What's that made of again?
Excuse me.
What's the material again?
Oh, what is the material of this? You remember? Carbon, silica, and germanium. No, semiconductors. For that reason, in all the computers, when you open the computer in your home, you find the circuit board, no? And what is the element located in front of the circuit board? The fan. Why? If the temperature of this material increase, that semiconductor become metallic and short. For that reason, say to your wife and your daughter, Mommy, don't use the laptop on the bed because you don't have ventilation and the circuit board explode. Yes or no?
Yes.
Mommy, don't use it. Go to the table. Or put a fan. You know the board with fans, and you put the laptop over there is to protect this circuit board, to avoid that element become metallic. Become metallic and finito, short. No, it's damaged right now because a couple of elements enter in short. Minimum.
What temperature does it become metallic?
Depend, but it's not too high. It's 120 degrees Fahrenheit. It's,
For germanium or
excuse me?
silica? For which materials?
Ah.
All of them?
Yeah.
120?
Yeah. All right. Okay, guys, pay attention. Suppose that you are the engineers. This is the group of engineers. Mickey Mouse engineers. This is the group of engineers, and your job is create the computer and the harness for the new engine Volkswagen that is invented over there for other group of mechanics, but that they need the electronic part. And you say, okay, you design the circuit for fuel. You design the circuit for cranking and stop. Each two people is responsible of one circuit. And you say, okay, I am going to create my circuit individually here. I am going to start with the battery. This is the negative of the battery, the positive. This is the switch. And after that, the switch, I am going to install the sensor. And after the sensor, I am going to install a capacitor here to reduce the voltage. After that, I am going to connect one resistor to increase tan. And after that, I am going to install here an LED for this, and pam. And finally, this is my circuit. This is my circuit for the emergency light. Okay. Okay. Now I go in one board like this, and I insert one cable from here to here, other from here to here, install the switch over there, and after that the resistor, and you create one Mickey Mouse circuit here, and you check with the battery, the input is 12 volts and the output 3.7. Great. My circuit is good. This is the circuit for the injector, and you are responsible for the circuit for the fuel pump. You create other circuit for the fuel pump. When you have all the circuit, 1 circuit, 2, 27 circuits, you go to other company, other engineering company, and you say, hey, my friend, I have 200 circuits. I need to create a board with all of those circuits integrated in one board. You know? And you create the path per each individual circuit. Look at this. This is the path for one, this is the path for other one, and in the bottom you have the picture of resistor, capacitor, all the elements that you need to connect. You see? You have the path individual per each one, and in the back you have the picture of what element should be connected over there. You know? The path individual and the elements. You see the elements? Resistor, capacitor, transformer, and this is the path. And look, this is the input of information, and this is the output. You see? And one of these is the positive bus bar and negative bus bar. You see? Positive bus bar and negative bus. You create a board like the board that you did in wood, smaller here, with all the circuits integrated. Anybody follow me? What is the name of this board? Printed circuit board, because you have printed each circuit. And now other experts connect the resistor and soldering, connect the capacitor and soldering. They don't know nothing about electricity. The only that they know is soldering. When they finish to soldering all of those elements, capacitor, diodes, and they soldering in the back, you have the circuit board. Finito. You like it? That's the process to create a circuit board. The cost? You see? And you see the paths in the back? Individual? Nice, no? And after that, when you finish with that, with the printed circuit board, you go to other company and you say, I need that you organize that the output cables enter in pins and the input cables enter in pins, install the socket, the case, and create this case for the computer. That circuit board, excuse me, 1 second, that circuit board is inside of this and is covered with resin. And look, the input pins are here, and the output pins are here. And now, I am going to put in Amazon, in eBay, the computer for that engine. Nice, no? Why they cover it with resin? Oh, you see. It's covered with resin. You see the capacitors, everything is covered with this gel. It's gel.
That's the resin, not the black.
That's the resin.
The black.
You see? Why they cover it with resin, the circuit board?
Moisture.
Moisture, that's number one, thank you. To avoid short.
Protect.
And to avoid that in the future the people repair the board. And in order to, one element is damaged, you need to replace the computer. Because if you sell the board open like this, the people desoldering and replace the resistor that is damaged and recover the board, $1,200.
So in most cases you find it like that though, and you don't find it open, you know.
It's depending of the design. For example, the generators, Western Big and Kohler, they use this board, open. But the Caterpillar, they use enclosed board because they don't want that you repair the board. That's the manufacturer, no? Until this point is clear, my friends? The definition of the circuit board? Oh, okay. How many, for what reason, excuse me, thank you. For what reason this computer, hey, my friend, how are you? Have a seat, please. Can you bring more seats over there, please? For what reason the price of this computer is $1,500, $2,000? Let me tell to you something. How many hours a group of 27 people spend calculating, number one, the circuit. After that, creating the board for one circuit. After that, converting the board in a printed circuit board. After that, converting the printed into that. How many steps are in this final job? A lot. How many hours? Now you understand why this is $2,000? Ah, $2,000. Yeah, $2,000 is too much people working on those elements. This one is $800. $800 for a small engine. Incredible. But that's the value. That's the price of the job.
Do all those get handmade or are they also machine made?
Okay, let me explain something. Handmade,
Like
the majority.
all
the
boards?
majority.
Wow.
Okay, at the end, when this process is when this process is repeated 1 time, 2 times, 3 times, and you have cleared the process, you visit China. The airplane, China. In China, the guys see the circuit board that you spend a lot of hours preparing here, and you say to them, hey, my friends, I need a circuit board like this. Smaller, if it's possible, than this. Oh, yeah. The Chinese guy says, oh, yeah, we can fabricate. How many you need? Okay, 1,000. Okay, for 1,000, each one will be $50 each one. But if you order 1 million, it's $2 each one. Each board, $2, yes. But if you order 5 millions, it's 0.5 cents each. They have the proportion, depending how many equipment, how many board you need, is dramatic different. And they design other ones smaller, perfect, but everything is with robots. They solder in the capacitor. But the number one was calculated, was designed by hand. You understand? And at the end, if you want to fabricate the radios or transistors, you need order million of this. And you order in China for $1.50 each board. Can you fabricate here in the United States this board for $1.50?
No.
That's impossible. That's impossible because it's. Oh, you understand what is the meaning of that? Okay. But the most magic situation is this. Pay attention. If I put 12 boards like this together, you need a computer like this, no? That's not good. Okay, you need a computer. Okay, can I, Mr. Chinese, can I reduce that board more? No, this is the minimum that I can. It's too much space. I have 12 boards in my design. Oh no, I can convert this board in one small microprocessor.
Damn.
Like this. I can convert this in this. Hey, my friend, I have 12 inputs and 12 outputs. Yeah, you have 12 inputs and 12 outputs. And everything is integrated here in the microprocessor. Excuse me, this is the microprocessor for my engine, yes. And this one, the other one, is for the transmission. And that one is for the electrical system. And that one is for the air condition. And you integrate all of them, 12, with a fan in a small board, and that's the computer of your car.
What's the cost?
Oh yeah. No, but finally, if you order millions, each of these is $0.7. That one. Yeah, but, but you know, it's a process, no? Excuse me 1 second. What is a microprocessor? It's a board condensed in that small element. What is the material of the microprocessor? It's silica and germanium. Where is produced the majority of the microprocessors in the world?
China.
In the Silicon Valley in California. You know? For that reason, those guys are millionaires, because they produce millions of electronic components like this per second. per second, per millisecond.
How much would it cost just to order one custom microprocessor?
Papi,
$5,000.
really about prices, I don't know, because this is a chain. I don't know. I know the process.
Okay. What did you have it in? What was that pink thing? No.
The printed circuit board.
What is that? Is this just to hold it?
Oh, this is a foam only to protect the microprocessor. This is the microprocessor to replace this. This is the microprocessor to replace this. Papi, this is not magic? It's magic, no?
¿Así?
Look,
Oh, that's small, man.
the same amount of input and output, inputs and outputs.
It's like a little spider.
This is the microprocessor. Wow, no? It's incredible. It's incredible. Oh, I have a problem in my engine. This is the final computer for my car. I have a problem in my engine. Only in this microprocessor. Can I replace only that now? You need to replace the board completely. Yeah, because it's covered. No? Questions until this point? What is the first step? Oh, create the circuit. That's the number one. I want to create the circuit for fuel. And I am going to be 300% sure that that circuit works. Perfect. And after that, I pass the circuit, that circuit into a board like this. And I solder it in the back, and I check with my multimeter the input and the output. My circuit is good. After that, you introduce this circuit in other circuit board, and you order printed all the circuits. And after that, you install all of those components in the printed circuit board. And after that, you convert this board into a microprocessor. Magic. This is magic. What is the process to convert this into this? I don't know. I don't have a speed.
They must be good, bro.
Okay, good. Today, guys, we are going to start to create circuits. And we are going to do a nice circuit board. We are going to create a rectifier. Somebody have the charger for a cell phone, please? You don't have in your bag the charger for your cell phone? The charger or your cell phone is one small box, plastic. You connect into the outlet, 120, and in the other output you have 4.2 volts or 3.7 volts for the cell phone. But what is the current in the outlet, in the wall? 120 AC. And what is the output? 3 volts DC. You need to convert that signal into a straight signal. And what is the name of that box? Excuse me? Battery charger or rectifier, because you rectified this signal into a straight signal. Okay, we are going to do in this class, in between today and tomorrow, the circuit for the rectifier. And we are going to connect at the input 120, and we are going to read with the multimeter in the output 12 volts or 14 volts DC. Because we are going to create with diodes and capacitors and resistors that circuit, and finally we have in the output. This is one circuit, only the rectifier. Let me tell to you something. All the computers that you have, internally, they work with DC. However, you connect your computer to the AC outlet. It's because the first step in the circuit board is rectified into DC, and after that everything is DC. In the TV, in your home, everything is DC. But the first element in the big circuit board is a rectifier. We are going to create the rectifier. Good? Great? Okay. The rectifier is an important element. We are going to create a lot of elements, but we need the rectifier. Let me tell to you something. With this technique, my friends, with this technique, the technique to create a circuit with input and output, you can solve millions of problems in the future in your boat. For example, pay attention. I have a problem. I am in Bahamas, and my engine no start. I discovered that no power is coming into the injectors. I checked in the manual and I found it that I needed 4.7 volts to activate the injectors. But I checked with my multimeter and pins that the pins 14, 15, 16, 17, and 18 dedicated for the injectors, the output is 0. In other words, the computer is damaged. I need to replace the computer, but in this moment I am over there. I don't have computer. But I need to bring the boat to Miami to fix it. Okay, I can create a circuit here with the input 12 volts and the output 4.7. And I activate constantly the injectors. Okay, the engine starts, but the black smoke too much is rich mixture. Okay, but I can use the engine with rich mixture, and I bring the boat. Anybody follow me? You can create different circuits to solve specific situations with a small board like this. For that reason, I have in my car, in my minivan, a lot of boards, a lot of capacitors, diodes, resistors. Diode, I need diodes. You remember what is the diode number 1 that we installed in the previous class? Can you refresh me where is located that diode?
Alternator output.
And in the output of the alternator, you remember, to protect the winding of the alternator. Yeah, this is one diode. But there are millions of diodes in different applications in your boat. And probably you need to replace those diodes in the future. Right? Until this point is clear? Okay. We are going to play a little with resistors. But before we play with the resistor, I want to explain something about the solenoid valves and the relays. Let me demonstrate. I create that board only to activate the fuel pump, the sensor, and now the engine is running with my board, because the computer is not producing power for the fuel system. Everybody follow me? Oh, let that one permanent. No, this is a temporary solution. We need to replace the computer, because this is a Mickey Mouse solution only to demonstrate to you that you don't have fuel. So, oh no, put over there and with the electrical tape. No. It's only to demonstrate that you need to replace that computer. Always you need to demonstrate to the customer that is for that reason. No, because I think that it's the computer. No, I can demonstrate that the computer is damaged for this. Look, yeah. Always demonstrate to the customer. No, blah blah blah. No, because I think that it's the sensor. I have a lot of students that and technicians that call to me every day. Mr. Lopez, I replaced the oxygen sensor 5 times, and the code continue in the display, oxygen sensor, and the engine shut down. Hey, my friend, if you replace the sensor 5 times, the problem is the sensor?
No.
Of course no. The sensor is an indicator. The sensor says, okay, the oxygen sensor is activated for some reason. Oh, replace the sensor. No, papi. The sensor is a speaker. Okay, you need to identify where is the problem. What sense the oxygen sensor? Oxygen sensor. Oxygen. What sense? Oxygen. Sense the amount of oxygen in the smoke, in the gases. Oh, if the level of oxygen is below the limit, it's because you have too much contaminant. And the engine shut down. Finito. Difficult? Okay. Sense the amount of oxygen. Okay, why I have less amount of oxygen than the limit permit in the output? Oh, because the fuel is contaminated, because the oil filter is clogged, because my fuel is mixed with water, because this, yeah? You have a lot of positives. Oh, you need to eliminate all of those. Start it again. Oh, no more code. You know? It's not the sensor, papi. And the people replace the sensor and the sensor. You need to be more analytic in the future. Because you are engineers, not technicians. Yes or not? The technician only replace. Hey, papi, replace that for me. Hey, papa, why you replace? No, because my boss says that replace. But no, that's not true. No, he said that replace. Okay, you are a technician, Mickey Mouse technician. I need to speak with the engineer. Where is the engineer? Ah, that guy. Why you replace the pump? Oh, because the temperature here is high and the pressure is. I think that. Ah, okay. No, that's the difference. You will be engineers, not technicians. Okay, guys. We are going to use. You remember what is the main difference between a relay and a solenoid? The solenoid produce external mechanic, but in the configuration, this relay and this relay is the same. This is a relay and this is a solenoid, because this one, additional to the relay, have the plunger. When I bring power 85, 86 to this relay, what happened with the external metal? And close the flow. Bingo. This is the check valve, solenoid valve. It's a solenoid valve activated with 85 and 86. You remember? This is 85 and 86. And the flow is interrupted or is allowed. It's basically one piece of metal opening and closing. This is a solenoid valve. There are millions of applications of solenoid valves in your boat. This is another solenoid valve. You see this? You see the relay? You see the relay, the terminals of the relay? And the flow is interrupted in that valve. Good? This is another example, other solenoid valve. There are millions of applications of solenoid valves in your boat. For example, in the transmissions, the marine transmissions, in summer, in September, we have transmission, classes of transmission. And we are going to study the diesel inboard transmissions. In the inboard transmissions, you have a solenoid valve. Depending which solenoid valve is activated, the fluid goes in this direction and the transmission spins in one direction. If the fluid is going in the other direction, the fluid enters over there and the transmission is spinning in the opposite direction. That's hydraulics. It's nice. But this is with solenoids. And we are going to use a lot of solenoids in the future, in the next coming class. In auxiliary system, the freshwater system is activated, is powered or not with solenoid valves. Great? It's clear? What is the process? Check a solenoid valve is exactly the same like check a relay. Once again, I want to know if this relay is good or not. Can you explain to me quickly what is the procedure? You have this relay in your hand and I say, hey my friend, demonstrate to me that the relay is good or damaged.
Check continuity between the prong.
Continuity between what?
The different pins.
Okay, I am going to check continuity with my multimeter.
You can use power clip, right?
And I need power also. I need power with a couple of alligator cables. Okay, with no power, PP, no? Okay. Can you hold it, please? With no power, what happened in between 30 and 87? Nothing. In between 30 and 87A? PP. Yeah? That's with no power. With power, positive and negative, I am going to power. Which terminal you power?
30.
Excuse me?
No, the
85 and 86. Roqueta. You hear, no?
Yeah.
This is the other indicator. Okay. And now what happened in between 30 and 87? PP. Right? This is it difficult?
No.
You need one battery and you need the multimeter. And you need the most important. Good? That's the solenoid. How many of those solenoid you need to keep in your car, in your minivan? What is the price of this solenoid 1 week like this in Bahamas, in the middle of the sea? $2,000. The engine stops suddenly. You enter, you identify that the run relay is damaged. You go to the captain and say, yes, my friend, I found the problem. I spent hours. Hard, difficult. The solution, quickly, is $2,000. No, my friend, yes. Okay, go ahead, because I have the people here. Tingale, 2,000 for me. All right? But you need to spend a lot of hours. Hard. I need to remove the panel in the back because it's covered. Too hard. Because you say 2,000, you need to demonstrate that. Hard. But it's too simple. Other common problem in both is this. Mr. Lopez, I don't know what happened. When I start the engine directly over there, the engine starts. But when I go to the fly bridge, no start, nothing. Normally, what is the problem? Pay attention. On the fly bridge, nothing. If you start the engine directly in the control box, start immediately. The majority of the time is no ground. No ground in between what and what? Where is the ground isolated in that specific case? Pay attention. On the fly bridge, nothing. Here, start immediately. Excuse me?
On the negative bus bar.
The negative of the battery bank over there is not connected with the negative of this battery bank. Start. It started! 2,000. All right? $2,000. Remember, in all the engines, you have the circuit board, and this is the control box, no? Where you have the start, stop, and preheat button. Yes or not, guys? And you have that fuse on the side. This is the fuse for the entire power of the harness. This is other fuse that normally is blown for some reason, and the technician never checked that fuse. You press the fuse and the engine starts again. And internally, you find 1, 2, 3, and 4 relays. You remember? Start, stop, run, and some engines have the fuel separated and fuel. But the majority, they only have 3. Start, stop, and run. Good? Oh, this one is damaged. You remove that one, you check, you replace for the new one, start again. Good? Okay, guys. All right.